Hello, everybody. Okay, let's wait for a few minutes before we start. Hi. Hello. Hello, everybody. Okay, let's wait for a few minutes before we start. Right, hopefully you have your handouts ready for now. Right, then we will start in 3 minutes. Okay, in the meantime, let's wait for the others to come in. Okay, hello. Okay, we have 1 more minute, then we can get started. All right, so it's already 4 p.m. So let's get started. All right, so today we are going to look at a different topic than what we learned last week, right? Last week, I believe everyone is getting very troubled by our model diagrams, right? But today we will go through something quite fun, right? It's the law of addition and multiplication. Now, you might ask, teacher, I already know how to do addition. I might already know how to do multiplication, right? Then what's the point of this lesson? Today, we will see how we can use addition and multiplication for easy counting. Okay, so with that, let's start our lesson today. Okay, so hopefully you have gotten your books and have been practicing on it, right? Especially the past year papers, right? The recent few years has been quite tricky, right? So hopefully everyone gets them done, right? And in preparation for Sasmo. Okay, so let's take a look at this analysis about past year papers to see where did addition and multiplication appears in, right? It steadily appeared one question per year until in the recent few years, you will realize, it appeared quite a lot of times, right? Especially in 2024, okay? So we want to get prepared, right, for these sort of questions in 2026, which is why everyone is here today. So without further ado, let's get started. All right, so let's take a look at this scenario here, right? One day, teacher Yong Lam wanted to buy a burger, right? There are two places whereby he can buy it, right? He could buy it from Burger King or he could buy it from McDonald's, right? In Burger King, there are 1, 2, 3, 4, 5, 6, 7, 7 burgers for him to choose from. And in McDonald's, there's 1, 2, 3, 4, 5, right? Teacher Yong Lam can choose 1 out of 5 burgers. So how many different ways are there to choose one burger, right? Type your answer in the chat. How many ways are there for teacher Yong Lam to buy one burger? There are 7 in Burger King, 5 in McDonald's. Okay, Eli, answer carefully. Don't make jokes. All right, so then how many ways are there to choose a burger in total, right? If some of you are still a bit confused, let me ask you this question. Do we need to buy from both shops at the same time, right? Teacher Yong Lam wants to buy one burger. Does he need to buy from both Burger King and McDonald's? No need, right? Teacher Yong Lam only needs to choose one burger from Burger King or from McDonald's, right? So the total number of ways is he either chooses one of the 7 from Burger King or one of the 5 from McDonald's. In total, there are 7 plus 5 equals to 12 choices. So he can choose a burger in 12 different ways. Okay, so what is the moral of the story here? The moral of the story is, right, just now, teacher Yong Lam buys from either Burger King or McDonald's. If our choices are presented in the either or case, we will use addition to calculate the total number of ways to perform an action, right? We don't buy from McDonald's and Burger King at the same time. Only one shop, only one event will happen, right? So in conclusion, if we want to choose either or, right, either Burger King or McDonald's, the total number of ways we will use addition, right? It is 7 plus 5. Good job, everybody. Okay, so it's 7 plus 5 equals to 12. Now, let's take a look at another situation here. Teacher Yong Lam, the next day, wants to buy one burger and one side. Side means a snack, okay? So how many burgers are there for teacher Yong Lam to choose? 1, 2, 3, 4, 5. 5 burgers. And there are 1, 2, 3, 3 sides. So if there are 5 burgers and 3 sides, how many ways are there for teacher Yong Lam to choose one burger and one side? Okay, teacher Yong Lam needs to choose one burger and one side. How many ways are there for teacher Yong Lam to do it? Right, you might think, it must be 5 plus 3. Right, 5 plus 3 is 8. Now, I need to ask you, okay? In this situation, do we need to buy both a burger and a side at the same time? Do I need to buy a burger and a side at the same time? Yes or no? Right, read the question carefully. Answer me, yes or no. Do we need it at the same time? Yes, very good job. I see a lot of you very clear about this situation. We need to buy a burger and a side at the same time. Right, so how could teacher Yong Lam choose? If teacher Yong Lam chooses the cheeseburger, he could choose either the nuggets, the fries, or the wedges. So he can choose this with the nugget, fry, or wedges. If he chooses the filet o fish, again, nugget, fries, or wedges. Big Mac, nuggets, fries, wedges. Cheeseburger, double, nuggets, fries, wedges. McChicken, nuggets, fries, wedges. For every burger that he chooses, right, that I choose, I can have 3 sides to choose from. Okay, so the way to calculate is 5 times 3 equals 15. I am using multiplication here because this is like a matching problem. All right, good job, everybody. Stop spamming in the chat. Thank you. So here we learned about another principle called the multiplication principle. When we want to calculate the total number of outcomes in the AND case, where events can happen together as steps, we will use multiplication, right? To sum it up better, if I need to choose one thing and then the next thing, right? It's sequential, one thing and then the next thing, we will use multiplication. Okay, so with that, this is a summary, right? Addition is for the either or case. Multiplication is for the and then case. Choose one and then the next. All right, now without further ado, let's take a look at how it works with some practice problems. Okay, get your handouts ready. Let's look at the first question. Okay, we see that Safa is picking her shoes. She has 3 different sneakers and 2 different sandals. How many ways can she decide what to wear? Right, the numbers are pretty small. It should be pretty easy. Right, I'll give you 10 seconds. Right, what's your answer? Please type it in the chat. 3 sneakers, 2 sandals. Right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 8. Okay, some people say 3 times 2. Some people say 3 plus 2. Okay, so let me just ask you the key question. Does Safa need sneakers and sandals at the same time? Don't get confused by this and. This and just means what she has. Okay, but think about what she needs to choose. Does she need to choose sneakers and sandals at the same time? Or let me ask, is she choosing sneakers or sandals? Or is she choosing sneakers and then sandals? Right, just ask yourself, is this an or case or a and then case? Okay, do you need to wear sneakers and sandals? Right, if I give you sneakers and sandals, do you need to wear both? No need, right? If you are choosing either one, right, you either wear sneakers or you wear sandals. You won't wear both, right? You only have 2 feet. Okay, so if it's an either or case, we will use addition, right? Either sneakers or sandals, right? She is choosing either sneakers or sandals, so we use addition, right? So in total, there are 3 plus 2 equals 5 different choices. Okay, so whenever you see some choice, think about it. Am I choosing either or am I choosing this and then the next? If it's either or, we will use addition. Okay, hopefully everybody is clear. This is an addition principle problem. Okay, addition principle, please use your mind to think. It's for either or case. Okay, now here we have the next scenario, right? Everyone, let's read the question together. Johnson has 3 different t-shirts and 2 different pairs of trousers. He needs to choose 1 t-shirt and 1 pair of trousers to wear. How many different outfits are there to choose from? 3 t-shirts and 2 pairs of trousers. He needs to choose 1 t-shirt and 1 pair of trousers. Now, this time, is it 3 plus 2 or 3 times 2? Okay, does it get hard? Well, this is an introduction, so I will keep things gradual. Okay, so is this question's answer times or plus? Okay, wow, I see so many people answering very quickly. Very good. Okay, for those who are still confused, let me ask you the same question again. Does he need a t-shirt and a pair of trousers at the same time? Right, does he need to choose clothes and trousers, or is it either clothes or trousers? Think about it. What would you wear when you go out? Okay, right? Yes, you guys already gave me the correct answer, right? So usually, right, 99.99% of the time, you will choose t-shirt and then trousers, right? You will need one of both at the same time. So you need to first choose a t-shirt and then choose a pair of trousers. If you are choosing t-shirt and then trousers, then you are basically doing matching. So you use multiplication, right? You can either match the orange shirt to any pair of the trousers. That's 2 ways. Blue shirt to the 2 trousers. That's another 2 ways. Green shirt to the other 2 trousers. So that's another 2 ways. Right. He needs to choose a t-shirt and then a pair of trousers. I'm choosing both at the same time. So it's total 3 times 2 equals 6. Okay, there are 6 outfits. If I'm choosing one thing and then the next, right, I have to choose both one by one. You use multiplication. Okay, so with that, very good job, everybody. You have gotten the correct answer. Okay, so either or means you just choose one of everything, right? One among everything. But for and then each category, you need to choose one. Okay, so with that, can I move on to the next question? Right, this time I don't have any pictures. You just need to read the question and try to identify. Right, we have 3 girls, Anna, Belle, and Cindy, and 4 boys, Dan, Eric, Frank, and George. They are playing a game. They need to form teams of 1 boy and 1 girl. So every team has 1 boy and 1 girl. How many different teams can we form? Okay, everyone, 10 seconds. Please write down the answer. Okay, for the 1% of the time you're wearing dress, right, for the girls. Okay, so yeah. Now, what do you think? Okay, we have 3 girls and 4 boys. We want to form teams of 1 boy and 1 girl. Do you use addition or do you use multiplication? Right, we are choosing 1 boy and 1 girl. Right, are you doing addition or multiplication? Wow, I see so many answers coming in. Very good. Okay, so now we use multiplication, right? Because we are choosing 1 boy and then 1 girl. Every category we need to choose one. So we will use multiplication, right? If it's boy and then girl, we use multiplication. So the answer is 3 times 4 equals 12. There are 12 different teams. Got it? Okay, choosing one thing and then the next. That is when we use our multiplication principle. Okay, now are you ready for the next question? Let's take a look at the next question. Are you ready? Okay. Oh, everyone is ready. Can I play from the start? You can watch the playback later. Okay, or you can just go to YouTube to check. Okay, which book and which page? It's the handouts, right? I've sent in the group since yesterday. All right, now let's see. Mike is planning to go to San Diego for his summer vacation, right? He can either take the train, take a car, or take a plane, right? So there are many ways to visit San Diego, either by train, or by car, or by plane, right? The keyword is already hidden inside my sentence just now. Every day, there are 4 trains, 3 cars, and 2 flights available. How many different ways can Mike choose? Right, so he wants to visit San Diego, and he needs to choose one way. Now, can you figure out? In this case, do you use addition or multiplication? The same question you need to ask yourself. It's the same, right? Are you choosing either or, or are you choosing one thing and then the next? What are you doing, right? Wow, some answers in YouTube. Okay, very good. Okay, more answers, please. Okay. All right. Question 1, question 2, question 3. No worries, I will send the handouts again after the live stream, okay? So over here, the question already said you are either taking the train, taking a car, or take by plane, right? By going to San Diego, one mode of transportation is enough. All right, so in that case, we are doing an either or case, right? When it's an either or case, we will use addition. So therefore, there are 4 trains, 3 cars, 2 flights. So add them up. Altogether, there are 9 available ways to choose to visit San Diego. Okay, any questions so far? Okay, so please remember, if we are using in a case where it's choosing either something or another thing, right? You don't have to choose both at the same time. You use addition, right? If you are using multiplication, that is for cases where you are choosing from one category and then the next category. Okay, either or is using addition. One category and then the next, we are using multiplication. All right. Okay, so now hopefully everyone is very clear on when to use addition, when to use multiplication. Now let's look at a special scenario of the addition principle just now. Okay, stop spamming in the chat. Stop them. Okay, now there are a new warm-up question. Let's see what this warm-up question is saying. Okay, there are 4 people in a group. Just nice, right? We have teacher Olivia, teacher Renata, teacher Liz, and teacher Yonglap, right? The 4 of us in a group. They need to shake hands with each other, and only one handshake is happening between every 2 person. That means every two people, they will only meet each other and have one handshake, right? There's no repeated handshakes. So how many handshakes are there within the group? Okay, so let's start off with a very simple question. One handshake requires how many people? One handshake is between two people, right? So let's first look at this picture and maybe list out where are the handshakes, okay? We start off with teacher Olivia. Teacher Olivia can have a handshake with teacher Renata, right? She can shake hands with teacher Renata. That's one handshake. Who else could teacher Olivia have a handshake with? Other than teacher Renata, right? One handshake later, she can also have a handshake with teacher Liz, right? Okay. Some of you are very close to the answer. Okay, look carefully. Then teacher Olivia can also have a handshake with teacher Yong Lam. So altogether, there are how many handshakes that teacher Olivia can make? Look at the arrows. 1, 2, 3. Teacher Olivia can make 3 handshakes. Okay, so up till now, we have 3 handshakes already. Let's take a look at the next person, teacher Renata. Right, teacher Renata also wants to have a handshake with everyone. Now, she proceeds to have a handshake with teacher Olivia. Does she need to shake hands with teacher Olivia again? Does she need to have a handshake with teacher Olivia again? No, because previously, teacher Olivia already had a handshake with her. So if she shakes teacher Olivia's hand back, that's a repeat, right? But we already said every 2 people, there's only 1 handshake, right? So teacher Renata don't need to go back and shake hands with teacher Olivia again. However, who could teacher Renata shake hands with? She can shake hands with teacher Liz and teacher Yonglam, right? That's why there are 2 handshakes. Okay, teacher Renata can initiate 2 more handshakes. Okay, now are we done yet? We just considered teacher Olivia, teacher Renata. Now let's take a look at teacher Liz. Does teacher Liz need to go back and shake hands with teacher Olivia? Does teacher Liz need to go back? No need, right? Because previously they have already shaken hands already, right? And similarly, teacher Renata also shook hands with teacher Liz, so he doesn't have to go back as well. However, who hasn't shaken hands with teacher Liz? Right, teacher Liz is here. Who does he still need to shake hands with? With me, right? We haven't shaken hands, so teacher Liz will still need to go to his right and have 1 handshake with me. So there's 1 new handshake that we found. And now let's look at teacher Yonglam, right? Now, does teacher Yonglam still need to have any handshakes with anyone? No need, right? Teacher Olivia already shook hands with me. Teacher Renata already shook hands with me. Teacher Liz already shook hands with me. So actually, I've already shaken hands with every single person. So there are no new handshakes, 0 new handshakes. Okay, so now that we have looked at all the scenarios, can you tell me how many handshakes are there all together within the group? Okay, so this time, do we add or do we multiply? We add, right? 3 plus 2 plus 1 plus 0. The answer is 6. Okay, so there are in total 6 handshakes. Okay, 6 handshakes in total. Okay, so this is a question where essentially we are counting how many pairs are there in total, right? We need to choose a pair of people. We need to choose a pair of people to do something. How many ways can we choose a pair of people? When we are choosing a pair and the 2 people are at equal ground, meaning A and B is the same as B and A, we will use this method called the shooting method. Okay, shooting method, what do? First, we will arrange all the people in a row, right? We arrange all the choices in a row. Then we will start from the left, right? Start from the leftmost person, and then we shoot to the right to see how many choices there are. Right, shoot to the right. Teacher Olivia, shoot to the right. She can have handshakes with 3 people. Teacher Renata, shoot to the right, 2 people. Teacher Liz, shoot to the right, 1 more person. Now, we don't need to go back to the left because it is repeating, right? We just need to always shoot to the right to prevent any repeats. All right, so when you read the question and see that we are finding the number of pairs and AB is the same as BA, right? Then you will use the shooting method. Okay, shooting method is a special application of the addition principle. So be very careful. Specifically, when we are choosing the number of pairs, we will use the shooting method. All right. Now with that, let's take a look at let's practice. Okay, I will give you some time right after reading the question. Let's see what the question has to say. The question says, an ice cream shop sells 6 different flavors of ice cream. Oh, teacher Yonglam just had ice cream a few days ago. He's very happy. Okay, so there are 6 different flavors of ice cream. Grace wants 2 scoops of ice cream of different flavors. Right, so what are we choosing again? The word that starts with P. A pair. Right, we are choosing a pair of flavors for the ice cream. How many different combinations are there? When you see the word combinations, right, this actually means that the order doesn't matter, right? The arrangement of the flavors doesn't matter, right? I just need a pair of flavors. Okay, can I give you 30 seconds to try this out? Okay, 30 seconds. Please type out the answer. Okay, if you are new to shooting method, maybe you can draw out the picture and then remember what is the method that teacher Yonglam taught you just now. What did teacher Yonglam teach you just now? Okay, now some of you, please be very careful, especially at the first shooting. What is the number of ways you can get if you shoot to the right from the first person? Okay, oh, I see some correct answers gradually coming here. Very good job. Okay, so if you need more hints, here is a diagram, right? A picture with 6 different ice cream flavors. Okay, and then try to shoot. Okay, now I didn't include this in your handouts, but it's okay. You can go ahead and draw it out yourself, right? It's just 6 circles. All right, so I see a lot of correct answers coming in. Very good job, everybody. Right, let's get started with this question. In this question, we are choosing 2 scoops of ice cream of different flavors out of 6 flavors. In other words, we are choosing a pair, right? When we are choosing a pair, let's see, for example, eating strawberry and chocolate. Is it the same as eating chocolate and strawberry? Strawberry, chocolate, chocolate, strawberry. Are they the same thing? Your cup will just always have the same 2 flavors. So choosing A and B is the same as choosing B and A, right? So when we are counting how many pairs there are, the method that we use is the shooting method. Okay, so let's use the shooting method, starting with the light pink flavor. I don't know what is this. Maybe it's lychee. Okay, now the lychee, right? How many ways can we choose a pair that contains this lychee? Right, we shoot to the right. Okay, we arrange everything in a row. Start from the left, shoot to the right. Okay, so from the lychee ice cream, I can shoot 1, 2, 3, 4, 5. So you see, I can actually pair 5 different pairs together with this lychee ice cream. Okay, so 5 ways if I select the lychee ice cream. Okay, now let's move on to the next person, the next flavor. Oh, this might be strawberry. Okay, how many ways can we pair up using the strawberries? I want new ways. Remember, I shouldn't repeat. Right, if I go back to lychee, lychee, strawberry, strawberry, lychee, do they mean the same thing? Yes, they absolutely mean the same thing. Your bowl will still have the same 2 flavors, right? So we don't go to the left, we only shoot to the right. So there are 1, 2, 3, 4. There are 4 new pairs, right? Let me draw the 4th one better. 4. There are 4 new pairs of flavors that we can form, right? By starting from strawberry and shooting to the right. Okay? Now, some of you might have already seen the pattern, but let me do this for one more time so that you see how many ways are there for the next person. Okay? The next one is, I don't know what is this. Blue. Maybe it's mint. Okay? So this flavor, again, you don't go back, right? If you go back, that's a repeat. So we go to the right again, right? How many ways can we form new pairs? Starting from the blue ice cream, 1, 2, 3. There are 3 new pairs of flavors that we can form. Okay, so at this point, do you see any pattern? We started with 5 and then 4 and then 3. So for the next one, chocolate, how many ways? Right, you again shoot to the right, 1, 2, 2 ways. Okay, Then for the taro, 1, shoot to the right, form 1 new pair. And finally, for the green, I don't know, maybe this is lime, okay? Is there any new pairs you can choose? No, right? When you shoot to the right, there's nothing else, right? So it's 0 here, right? So all we did is starting from the left, shooting to the right. And for every ice cream flavor, we found these many new pairs, right? We follow the pattern. We start from the number, and then every time we go to the right, it decreases by 1. Finally, to find the total number of ways, you just do 5 plus 4 plus 3 plus 2 plus 1 plus 0. Michelle won't stop. Okay, so that is equal to 15. Right, so answer statement. There are actually 15 different pairs or combinations of flavors that we that we can form, right? If we want to choose 2 ice cream flavors between 6 different flavors. All right, shooting method. That's it. Okay, arrange everything in a row. Start from the left and then shoot to the right. Okay, so that is the third technique, right? Addition, multiplication, and then shooting. Right, let's look at a little summary. When we are choosing a pair, like what we were doing just now, right? When we are choosing a pair, then we will use the shooting method. Okay, for the shooting method, you arrange all the choices in a row, then start from the left, then you just shoot to the right. All right, and then if we are not choosing a pair, we are given different categories of choices, but we choose either one category or another, right? Either or, we will use the addition law. And finally, if we are choosing something from one category and then something from the next category, we have to choose them at the same time. Then we will use multiplication principle. Okay, so read the question carefully and then figure it out. Okay, so with that, let's take a look at a very classic application of addition and multiplication principles, right? You will realize that, especially in recent years of Sasmo, right, other than shooting method, they like to come up with a specific type of question, which is forming numbers. So let's take a look at this warm-up. Now we have 5, 8, 9, 6. These are 4 digits, okay? Not cards, they are digits. And now teacher Yong wants to ask you, how many different 4-digit numbers can you form if you can use the digits above only once? Okay, so we want to use the digits 5, 8, 9, and 6 to form 4-digit numbers with no repeating digits, right? Meaning if I choose 5 for the 1,000, my hundreds cannot be 5. So how many ways are there to choose your numbers? Anyone who is fast can give me the answer directly? Aha, okay, some of you already pretty fast. So let's see how this works. So for 4-digit number, remember the place values of them, right? Starting from the ones, we have the ones, the tens, hundreds, and then thousands. Okay, so let's choose the digits one by one. Perhaps we can start from the thousands, right? How many ways can we choose a digit for the thousands? You can choose any of them, right? Could be 5,000, 8,000, 9,000, 6,000. So there are actually 4 ways to choose the thousands place. Okay, but what about the hundreds? Does that mean it is also 4 ways? Think about it. 4 ways to choose the thousands. How many ways to choose the hundreds? How many ways can you choose the hundreds? Is it also 4? No, right? Why? Let me give you an example. Let's say I chose 5 as my thousands digit. For the hundreds digit, does that mean I can choose any of the above? Right, for example, haha, I can choose anything, right? I can choose 5 again. Can I? Cannot, because we can only use the digits only once, right? In the formation of the number. So now I cannot choose 5 again, right? I should choose a different digit. How many digits are left for us to choose? If we cannot choose 5, there's still 8, there's still 9, there's still 6. So there are 3 ways. Then we move on to the tens. Tens, how many ways? Right. You will realize that the more I choose already for the remaining place values, there are less and less choices. Right. When I cannot repeat my digits, the choices get fewer and fewer. So at the end for the tens place, we already used 2 of the digits above. Right. So there are 2 choices left. So I choose one more. Then how about the ones? unfortunately, we already used up 3 of the 4 digits available. So there is 1 digit left for us to use. So the answer, there's 1 way to choose the 1's digit. Okay, so altogether, how many ways can you choose your 4-digit number? Now, my final question is this plus or times? Should I 4 plus 3 plus 2 plus 1? Or 4 times 3 times 2 times 1? What do you think? If it's plus, type plus in the chat. If it's times, type times in the chat. Is it plus or times? Plus or times, everybody? Plus or times. Ooh, very good. Okay, I see some people very fast reaction. Remember, plus if we are choosing either or. Times is if we are choosing one and then the next. Here I'm choosing thousands and then hundreds and then tens and then ones. So essentially I am multiplying the number of choices. Right? Choose the thousands and then hundreds and then tens and then ones. So there should be 24 such numbers that we can form. Okay, it's times because we are choosing one and then the next and then the next. All right. Okay, so that's for question 1. Are you ready for the next one? Now, this time, the next question is asking, how many different 4-digit numbers can you form if you use the digits above more, if you can use the digits above more than once? Meaning, do we have to use up all the different digits? No, we can repeat the digits this time, right? There is no restriction. So for the thousands, we have 4 digits. We can use any 4 of them. Hundreds, 4 possible digits. And we don't have to worry about not repeating, right? We can repeat. So we have the same 4 choices. Tens, same 4 choices. Ones, same 4 choices. So at the end, we are doing 4 times 4 times 4 times 4. Can you tell me the answer? 4, 4, 4, 4. Okay, at this point, you need to calculate well, right? The answer is 256. Okay, so when you can repeat, right, then all the choices are always available, provided there are no special condition. Okay, hey, multiply carefully, okay? It's 4 times 4 times 4 times 4. It's not 192, okay? And Michelle 11137, please stop spamming. Okay, stop spamming the PPPPP. Right, I can see you. All right, with that, this is the easiest scenario, but I have prepared quite some questions, right, that could be a bit tricky. So everyone, please open your eyes, read the question carefully, and underline the keywords before you start the question. Okay, so let's try out the first question. I am asking you, how many 3-digit odd numbers can be made using the digits 1, 2, 3, 4, 5, and 6 if digits cannot be repeated? Okay, so before you jump in and solve the question directly, please read the question carefully first. There are 3 key points that I want you to take note. Right, what are the 3 key points? We want to know what are the types of numbers or what the condition of the numbers we want to create. Right, the numbers must be 3-digit. They must be odd numbers, and the digits cannot be repeated, right? Digits cannot be repeated. So whenever you see so many conditions, right, make sure you don't just write down your answer right away. First things first, list out all the seeds, right, all the place values, and then consider them one by one, right? For example, since we are asking for 3-digit numbers, so you will draw 3 spaces, right? 3 underlines or 3 boxes, okay? Then we try to find out, okay, what are the special conditions? Now, there are the hundreds place, there are the tens place, there are the ones place. Can you tell me, among these 3 place values, is the hundreds or the tens or the ones the most special? Right, I'm asking for 3-digit numbers, I'm asking for odd numbers, and I'm saying that the digits cannot be repeated. Right, so many people are so fast, right? The answer is not 67, by the way, right? Please be more careful. Now, you see, teacher Yonglan was very much emphasizing the word odd, right? Odd numbers, odd, okay? So, the ones place value is the most special because it must be odd, right? The ones place must be odd. So actually, if we see a special place value, right? We need to consider that first. Here, the ones is the most special. So let's look at the ones first. The ones must be odd. How many choices are there to choose the ones place? Since the number must be odd, the last digit must be odd. There are how many choices? There are 1, 2, 3. Right, I could either choose 1 or choose 3 or choose 5. So there are 3 choices. Okay, there are 3 choices for the ones digit, either 1 or 3 or 5. Okay, so now we figured out the special condition. It's time to look at the other digits at the other place values. Let's look at the hundreds first. Okay, now I see some of it in the chat saying, haha, teacher, I know. Then that means there must be 6 ways here, right? There's no restriction. So I can choose all of the 6 digits, choose one of them and put it in the hundreds place. Is that correct? Right, think carefully. Are there 6 ways to choose the hundreds place? Right, I already said digits cannot be repeated. Digits cannot be repeated, right? So let's say I chose 1 for the ones place. And I choose 1 again in the hundreds place. Cannot, right? I cannot choose 1 again, right? So if I chose 1 in the ones place, there's 5 more choices for the hundreds, right? I could choose 2, I could choose 3, 4, 5, or 6, right? I could only choose a new digit that did not repeat with the ones. In other words, I already chose 1 digit for the ones. 1 choice was gone. How many choices are left for the hundreds place? 5 choices. Very good, right? Jiating said it's 5. So there are 5 ways to choose the hundreds. And then how many ways to choose the tens? Right, now I chose the ones. Now I chose the hundreds. 2 digits gone already. Right, now there are how many digits left for me to choose? Right, 6 minus 2 is 4. Let's say I already choose 1. I already choose 2. Then I will have 3, 4, 5, 6. 4 more ways to choose the tens digit. Right, good job. Okay, and then finally, what you need to do is you just multiply all the choices. Because remember, you are choosing 1 digit and then the next, and then the next, and then use multiplication. Right, 5 times 4 times 6, 3. There are 60 numbers. So the answer, there are 60 3-digit odd numbers. All right, at every point of time, think about how many digits are already used. So how many digits are left for you to choose from? Okay. Now, some people say, yeah, this is easy question, but I see a lot of careless mistakes, right? Some of you say it's 6 times 5. You forgot I cannot repeat the hundreds with the ones. So please keep this in mind when we apply the next question, okay? But this next question, right? Let's see. It's very short. Okay, I designed it like Sasmo. Okay, Sasmo sometimes I like to come up with these short and sweet questions. Okay, so how does this work? Okay, WJZH at 1, 2, 3, 4, 5, 6, 7. Stop spamming. Okay, I see your comments very clearly. All right, now how many 4-digit numbers are composed by only even digits? Right, how many 4-digit numbers? So what's the first step that you need to do? Should you list out everything? List. Right, I mean, you can, but when you list number 1, it's very time consuming. You will waste your time. Sasmo, you only have 3 minutes and a bit more per question, right? If you choose to list, you're wasting your time. Second, you might not list completely, and that's a waste of effort. That's why I'm introducing law of addition and multiplication today. Right, so the first step is to draw out the seeds and then consider them one by one. Right, so since it's a 4-digit number, let's draw out the 4 seeds. Okay, now my question is, among these 4 place values, right, which place value is the most special? Right, now before you answer my question, I know it's only even digits, right? Only even digits. So what are the digits that are even? What are the digits that are even? Some people say 500. Ooh, so fast. Okay, the even digits are 0, 2, 4, 6, 8. That means surely I can insert all 5 of them everywhere, right? But wait, teacher Yongnam, doesn't it literally said in the last question that our choices would decrease because we used up the digits. Right. So here I also want to mention, did we say that I cannot repeat the digits? Did we say that the digits must be different? In this question, did we say that the digits must be different? Oh, no, I didn't. Right, because I only said only even digits. I didn't say cannot repeat. I didn't say different digits. So actually, this question means that I can repeat the digits. So please read the question carefully, right? And figure out what are the conditions. Maybe they are given to you, maybe they are hidden. Right. So that means I can repeat 0, 2, 4, 6, 8 all the time. Pretty much everywhere I can put 0, 4, 6, 2, 4, 6, 8, right? Do you think I can put 0, 2, 4, 6, 8 everywhere? Or is there a very special place value? Which place value is special? A, B, C, D. Write down your answer. Is it A, B, C, or D? Okay. Right. Let me give you a hint that there's a 0 here. Right. Like what I said in class, 0 is sus. Okay, why is 0 sus? Ah, I see so many answers. Good, good. Okay, you see, huh? 0 is sus because, can I put 0 at the thousands, please? Can I put 0? Can I say, oh, a 4-digit number is 0,000 and can I? Cannot. Okay, Lina said the answer is D. Sure, the ones place, you can choose 0, 2, 4, 6, 8. But that's the same for all the other place values, right? All the other place values, I can also choose 0, 2, 4, 6, 8. Except the thousands place cannot be 0, right? A 4-digit number, right? The highest place value cannot be 0. 0 cannot be at the, can't be at the, let me write carefully, can't be at the highest place. Since it cannot be at the highest place value, what are the only choices for the thousands place? Right, stop spamming the Z's, okay? You can either choose 2, 4, 6, or 8. So there are 4 choices for the thousands place, okay? So when you see 0, right, you need to be very careful. 0 cannot be at the highest place. As for the hundreds, now I did say that you can repeat the digits. There's no restriction. So you can use 0, 2, 4, 6, or 8. 5 choices for the hundreds. Then again, 0, 2, 4, 6, and 8. 5 choices for the tens. Finally, 0, 2, 4, 6, and 8. 5 choices for the ones. And at the end, remember, you are choosing one and then the next, and then the next. So multiply the answers. And your final answer is 4 times 5 times 5 times 5. Your answer is, very good job, 500, right? Tips and tricks in multiplication, right? 25 times 4 is 100. Okay, so with that, we have gotten our answer. It is 500 numbers. So you see, every question that I introduce here is actually very important because I'm sharing a different tip in each question. Okay, 0 cannot be at the highest place. Then also pay attention to whether it's odd or even. All right, with that, let's take a look at the next question. In this question, what is the trick here? Right, let's read the question. Among whole numbers, right, whole numbers means you're counting numbers from 1 to 400. How many of them do not have repeating digits? Another short and sweet question. The number for the answer is not that trivial though, right? So what are the key points in this question? There are 3 key points. The first is 1 to whole number, right? But we will come back to whole number, right? This is the first. Second, 1 to 400, I am giving a range, right? Some of you might always forget the range. Okay, so read carefully. Bigger than, smaller than, right? What in between? So think carefully. Okay, if you, how about, I think that's you. Please stop. Okay, and then how many of them do not have repeating digits, right? So I cannot repeat the digits. Okay, I know teacher Yonglong will always ask me to draw out the seeds first, right? We need to draw out the seeds. Except, how many digits can this number have? Many of you will say, teacher, I know 1 to 400, right? 400. So definitely 3-digit number. Does it have to be a 3-digit number? The question say it has to be a 3-digit number. it just says whole numbers. It just says counting numbers. So it could be 3-digit. It could be 2-digit. It could be 1-digit. It's actually all of the above, right? So sometimes the question might be very sneaky. It did not mention how many digits the number had. In that case, you need to consider case by case, right? So this number could have 1-digit, 2-digit, or 3-digit, right? So we need to consider case by case, okay? Especially when the question did not mention how many digits your number has. Okay, with that, now let's just look at it case by case, right? First, the 1-digit number, very easy. 1-digit number. How many 1-digit numbers are there? Right? Since there's only 1 digit, definitely you cannot repeat. So actually, all of 1 to 9 is possible. There are 9 ways, right? So there are 9 numbers. Let me write it better. Any digit from 1 to 9 is okay. There are 9 numbers. What about the 2-digit number? Right? 2-digit number. Again, let's look at the highest place first. The highest place is very special because 0 cannot be at the highest place value. So it cannot be 0. But I didn't say what digits you can or cannot use. You can use any of them. Just that you cannot use 0 because 0 is at the highest place. So that means you can use 1 to 9 again. There are 9 ways, right? You can use 1 to 9 again for this digit. Okay. Aha! So that means that there must be 8 digits that I can choose from, right? For the tens. Because teacher Yonglam said before, every time the number of choices gets decreasing. Okay? Am I correct? Can I say it's 9 times 8? Is it 9 times 8? I haven't seen a correct answer yet. Think carefully, alright? Now, let me list out all the digits available, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay? So I want to form a 2-digit number without repeating digits. Let's say I picked 1 as my 10th digit. I used 1 already. Now, how many ways can I pick my 1's digit? You see, I can choose 2, choose 3, choose 4, 5, 6, 7, 8, 9, 0. And there are actually 9 choices this time. Right? Maybe I can choose 2. Maybe I can choose 3. I don't know. Right? But why is it still 9 choices? Huh? Why is it still 9 choices? Well, that's because at the 1's digit, now you can or may choose 0. Right? 0 could be a possible digit at the 1's place. It's just not at the 10's. Right? It just cannot be at the 10's. So then, I choose any digit from 1 to 9. For the 10's place, there are 9 choices. Choose one of them already. I can use the other 8 in the 10's digit, in the 1's digit. Sorry, 10's digit, choose 1 to 9. 1's digit, I can choose the other 8 from 1 to 9. And then I can also choose 0. So there are actually 9 ways to choose the 1's digit, as long as it doesn't repeat with the 10's. So in total, there are 9 times 9 equals 81 ways, or 81 2-digit numbers with no repeating digits. All right. Okay. Now, that's for the 2-digit case. Let's look at the 3-digit case. Okay. 3-digit case, again, I know 0 cannot be at the highest place, right? So definitely there are 9 ways to choose the 100th place, right? The highest place. Is this correct or not? Can I say, oh, there are 9 ways? Again, read the question properly. The question said 1 to 400. So what are the possible 100th place for a number from 1 to 400? It can be 1. It can be 2. It can be 3. Can it be 4? Well, actually it can. Right, because I said from 1 to 400. 1 to 400 means I include 400 in the range. But then if I include 400, do you want to count 400 in our number with no repeating digits? Well, I cannot consider 400 because 400 has 2 zeros that are repeating digits. So it is enough to consider 1 or 2 or 3. That means my 100th digit has 3 choices. 1, 2, or 3. Okay, so this is important. The range here might trip you because sometimes you might be only able to choose half of or part of the choices available. Right here, I said 1 to 400, so it could only be 100 something, 200 something, or 300 something. Okay, 400, repeating digits, don't need to consider. All right, now for the tens digit. Again, how many ways are there to choose the tens place? Now, we already chose one of the digits, right? 1, 2, or 3. So let's say again, I choose 1. Then I cannot repeat the same digit as the hundreds again, which means there are still, look at here, 9 more ways to choose my tens digit. Okay. Right. Wow, some of you got the answer. Good. Okay. Then from these 9 digits, I choose another one for my tens digit already. So let's say I choose 2 already. Okay. In that case, how many ways can I choose my ones digit? How many ways can I choose? Good, good. Good. How many ways can I choose my ones digit? There are still 1, 2, 3, 4, 5, 6, 7, 8. Still 8 ways to choose my ones digit. Okay, so in that case, 3 times 9 times 8 is equal to 216. Okay, so there are 216 three-digit numbers from 1 to 400 that do not have repeating digits. Okay, and then I tell you at this point, right, half of you will give me the answer as 216, right? You all calculated so much, and then you give me the answer 216. Is this correct? Is it 216? Read carefully, right? We are asking for in total. This 216 is only the 3-digit number, but don't forget you found the 1-digit and 2-digit numbers as well. So there should be 9 plus 81 plus 216 such whole numbers in total, right? So altogether, there will be 306. Okay, answer 306 ways. Okay, so there are 306 numbers with no repeating digits. Okay, this is a tough one. If you couldn't get it in first try, it's okay. Try to review this question again later. Watch the playback if you have any questions, okay? Watch and maybe ask me if you need my further explanation, all right? Okay, finally, let's take a look at the last question of today. Today, we talk about addition and multiplication principles, and there's a new vocabulary that I want you to learn. All right, let's look at this question. It's a real Sasmo question, by the way. Okay, a palindrome. Palindrome is a number that can be read the same forward and backward. Okay, a number that can be read the same forward and backward. For example, 99, 252, and 4884 are palindromes. That's because, for example, 252, you go forward, it's 252. You go backward, it's also 252, right? If you reverse the order of the digits, you still get the same number. So they are palindromes. Now the question is asking, how many 3-digit palindrome numbers are there? Oh, this time it is less evil, right? It's 3-digit. So straight away, list out your seats first, right? There are 3 digits. Okay, right? Winston Teo, stop. I see your answer, 19. Okay, is it 90 though? Let's check. All right, so among these 3 digits, let me ask you again, which digit is special? Which digit is special? Okay. Okay, wow, so many people already giving me the answers. Very good. Now, first, I can tell you the hundreds place is of course special. Because why? This is the hundreds place. Okay, hundreds place is the highest place value. Who is sus? Who cannot be at the highest place value? Which digit cannot be at the highest place value? Very good job. 0, right? So it cannot be 0, right? This place value cannot be 0. So we could choose from 1 to 9 for this digit. So there are 9 ways to select the hundreds digit. Okay, now imagine you selected the hundreds digit right here. 9 means 9 ways. Imagine you selected the hundreds digit. Then which digit is special next? You've already selected the hundreds digit. And remember, it's a palindrome, That means forward and backward, it should be reading the same. Forward and backward should be reading the same. Imagine I choose 2 for my hundreds, then I choose 3 for my ones, right? 200 and something 3, right? 203, for example. Then when you come back, is it still the same number? No. So this means, right, palindrome number means the starting digit and the ending digit has to be the same, so that when you go in either direction, right, you will have the same reading, right? Same start and same end. 203 cannot, must be like 202, right? Forward, backward, same reading. So there's one way to choose the ones, right? It has to be the same as the hundreds. The moment you choose your hundreds, automatically your ones is already chosen. There's only one way. Finally, how many ways are there to choose the tens? It's not 9 times 9 times 9, okay? You choose the hundreds, the ones have to be the same. So automatically, there's no other flexibility to choose the ones. For the tens, is there any restriction? There's no restriction, right? I could choose any digit from 0 to 9. I can choose any digit from 0 to 9. Because 0 now, this is not the highest place. I could put 0. I could put 1, 2, 3, 4, 5, 6, 7, 8, 9. I can also put. So there are 10 ways to select the tens digit. Okay? So with that, what's the final step? Everyone should be very familiar with it by now. Multiply the number of ways, because I'm choosing ones, sorry, the hundreds, and then the ones, and then the tens, right? Choosing one category and then the next category. So multiply all the choices. There should be 90 palindrome numbers. So the answer is C. Okay, some of you will say, it's 9 times 9 times 1. No, no, no. First, I didn't say that the digits cannot be repeated, right? For example, 2, 2 already, middle, I can still put 2. Right, so 2, 2, 2, it's still a palindrome number. In fact, 2, 0, 2, 2, 1, 2, 2, 3, 2, all the numbers up to 292, they are all palindromic numbers. So there are 10 ways to choose the middle digit, right? You can choose any of them. All right, so with that, the answer is C, 90. Okay, so this question is a bit tricky because it tests your understanding of a new concept, right? It's not just pure calculation or forming numbers, right? You need to understand the question. Okay, and with that, right, please read the summary carefully. When we are choosing a pair, what method do we choose? When we are choosing a pair, we choose to use the shooting method. Arrange them in a row, start from the left, jump towards the right. Okay, and if we are choosing either from one category or the other category, right, only choose one, don't need to choose from both at the same time. We use addition principle. However, if we are choosing one category and then the next category, right, remember it's multiplication principle. Okay, and with that, yeah, we are done, right? This is the weekly practice. Again, 10 questions, right, based on what we learned this week. When you're done, please submit your answers via the link. I will post it in both WeChat and WhatsApp later. Okay, the deadline is still by coming Wednesday, right? If you have anything you are unsure of, just take a picture and then find me. Okay, either through WeChat, WhatsApp, or rather, we will see you next Thursday. Okay, all the best. Please have a good week ahead. Okay, yay. All right, we have reached the end now. 5 p.m. just nice. Okay, everyone is free to go. Please remember, complete the practice. The practice problems, most of them are not hard today. Okay, I would say it's more manageable than last week's. Okay, all the best. Bye bye. Okay. See you. Bye bye. Do the practice. Okay.